All right, so we should be on this page here of our notes, and we are going to talk about circles still in this unit. So the last unit we talked a lot about circles and the difference between all those different types of angles, and if they were central, inscribed, if they crossed on the interior, if they crossed on the exterior. So we're still dealing with circles, but now we're going to switch gears a little bit and talk about something called radians. Radians versus degrees, okay? Why do we need to know about radians and degrees? Okay, so where does this come from? Why is it important for you guys to know? So most of you in this class, next year you'll take either Modern Algebra 2, or maybe you'll be on to the honors track, but eventually I would say the majority of you will probably be in pre-calc or calc by the time that you're a junior and senior. Okay, in that case, when you guys get to that point, especially in pre-calc, you'll talk a lot more about trigonometry. We've dealt with trigonometry in here, but we didn't get super detailed into it. We talked about sine, cosine, tangent. We talked about law of sines, law of cosines. Believe it or not, that was just like the surface of trigonometry. Okay, there's a lot more in that we just didn't get to this year because you're just not quite ready for it. Okay, but next year when you guys move on to Algebra 2, you'll talk more about trig. And then the following year, if you guys go to pre-calc, you'll spend a whole lot more time talking about trig and all the different things that you can do. And in that, there's something called the unit circle. The unit circle is just a way that we can look at how many degrees are in a circle and how we could rewrite it in terms of what we call radians. So I want to go over first with you guys today, what is a radian? So where does it come from? Why do we call it that? What does it look like? And what does that mean for us? Because we're used to seeing things in degrees. So now I want you to get used to, you could possibly use something in degrees still, but we could also use it in radians. So what a radian is, we're going to just write the definition here first. A radian is an angle that creates exactly one radius of arc length. So using kind of what we even did in our bell ringer today, I asked you on the bell ringer to draw an example of a central angle. And a central angle is created by drawing any two different radius in the circle, or radii. So over here, if I do kind of what I did on our bell ringer today, I'm going to draw a line segment going from the center to the edge. That would be a radius. Okay, and I'm going to draw another one in here, but I'm going to try to put it in a specific spot to show you what the radian looks like. So if you think about how long this radius is, if I was able to measure this somehow, okay, whether I had a ruler or I used a tool, just like a compass or something to maybe get that measurement, I could take this, and if I took this straight segment here and I brought it out to the edge of the circle and I tried to almost bend it and lay it on the outer edge, like the circumference of the circle, I could do that with however long this was. So if this was 5 centimeters, let's just say, I could lay it here and have it go 5 centimeters along the edge of the circle. It would then connect to another point, which we could also draw to the center, which is just another radius. So something like this. This distance in between, so kind of where I'm scribbling over here, this is known as the radian. That's the length, but now on the circumference of the circle, that would match the length of the radius of the circle. So if you think of the word even radian, it kind of sounds like radius a little bit. It's got a lot of the same pieces to it. So when you hear people talking in the future about radians, this is what they mean. We're taking a radius and we're laying that radius on the outside edge of the circle. Now the question then comes, how many times could we do this? How many times around a full circle could we have the radius be? Like if I started to do one and then I did another one and I attached it again and again and again to go all the way around my circle, how many times does it get until you get to the end? So over here on this circle, let's talk about that. We already know from what we've done even in the last unit how many degrees make up a full circle. You guys remember how many degrees go in this whole circle here? 360. Okay, 360 degrees is in a circle. Radians, though, is not talking about it in terms of degrees anymore. Radians is something a little bit different. It's this relationship between, like we've talked in the past, like pi, and how that relates to your radius. If you remember when we talked about circumference in the past, I'm just going to write this at the bottom. Circumference, we had two formulas. We had 2 pi r, or we had pi times diameter. Okay, I'm going to focus more so on the 2 pi r one. Because when I think about radians, it's directly connected to your circumference. You guys have done this before. You've had to find circumference of circles in the past. And when we did that, before we even started with circumference, we did a whole activity in class where we talked about what is pi. You guys had a website, you had to create different sizes of circles, and you figured out the relationship between the circumference and the radius was pi. I think you started with the diameter, but you still got to your pi. So when we think about this that we've seen in the past, how does this relate to our radians? Well, 360 degrees that goes all the way around your circle, that is the same. So I'm going to say, and exactly 2 pi radians. So the 2 pi radians is just like what we see down here in our circumference formula, 2 pi. Now r stood for radius there. So when I'm talking about radians, I'm not going to have like a r in the formula anymore. But if I go all the way around my circle, that's equivalent to 2 pi radians. And that's connecting to your radius length. What we're going to do with this today is more so how do we go between the two forms? How do we convert between degrees and radians? Like sometimes they'll want you to have it in radians, sometimes they'll want you to have it in degrees. And in the future, when you get to next year and pre-calc and all that, you'll spend more time on this. And you'll probably spend more time in the radians form. So this is just good exposure for you guys so you kind of can see that. And maybe you'll be able to pull on that information in the future. So down below, I want to go over how we convert between the two, okay? And then I'll kind of show you what this starts to look like on the circle off to the right. But so I'm going to talk about how you convert between degrees to radians and radians to degrees, so how you go back and forth between each way. They're fairly similar to each other. In fact, the process is the same. It's just one little piece that we work with is going to have to switch just slightly, but not anything major here. So to go from degrees to radians, so the first case here, what you're going to do is use pi over 180. If a full circle is 2 pi, then half a circle would just be pi, because half of that 360 would be the 180. So that's kind of where this relationship is coming from, is this pi over 180 here. So for example, I'm going to write a couple examples down here. Let's say that we start with 270 degrees. And I want to convert this to radians. What I'm going to do is first write 270 as a fraction. So I'm just going to put it over 1. And then we're going to multiply this by that pi over 180. Because this is going to help me get 2 radians. Now, when you do this, we're going to be doing a little bit of like reducing. Okay, so we can do some reducing here. Go ahead and just have a seat. I'll be right with you. So what we're going to do is reduce what we can. Now, if you're not great at reducing mentally, your calculators can help you. Okay, like you can just divide the 270 by the 180. You can divide that on your calculator. Your calculator will probably give you a decimal, but remember, you can hit that button that's right above the enter sign, and it'll switch it back to a decimal for you, and it'll be in its reduced form. Some of you might know, though, a number that you could take out of both 270 and 180. Anybody have a number that you could do that? 90. How many times can 90 go into 270? 3, and into 180? 2. Okay, so this would then become 3 pi over 2. And this would be radians. So it's this, again, relationship between the radius and that outer edge of the circle, how they connect to each other. So that would be 3 pi over 2. Okay, let me give you another example. So this next one, let's start with 120 degrees. And why don't you guys see what you can do with that? Okay, let's go over this one. So again, I would always write it as a fraction just because it's easier to think about what you're able to multiply. So I did this. Were you guys able to reduce it before? What did you guys do?
60 can go into both.
Okay, so then the 120 became a 2 and the 180 became a 3. So your final answer was?
2 pi
Good, 2 pi
over 3.
over 3. Again, radians. Now you could write out radians again, but you might also see someone write it like this, RAD. That's short for radians in math. Okay, so if you want to abbreviate radians, you can by just saying RAD. All right, questions on how to go from degrees to radians. So now we're going to go the other way because sometimes you might have something in radians and we want it back in degrees. We are used to seeing things in degrees in this class, so sometimes we might want to go backwards and figure out how many degrees is it. For this one, it's very similar, but instead of using pi over 180, you're going to do the reciprocal. You're going to use 180 over pi. The process is the same though. We're still going to multiply. So I'm going to start with an example here. Let's say we have radians pi over 6. If this is what I have in radians, what I'm going to do here then is take this now times 180 over pi. What's going to happen to my pi's? They're going to cancel. That should always happen when you're going from radians to degrees. There's a pi built in there, so it should just cancel off. Can 6 go into 180?
Yeah.
How many times? 30. So I'm going to just go ahead and do that reducing. So all I have left here is 30 over a 1, which I'm just going to write as 30 degrees. There's your answer. Okay, so let's do another one here. Let's say you have 5 pi over 4. We're going to do a similar process. We're going to take this times 180 over pi. Again, what cancels off right away? Pi. You can do some reducing if you'd like to. You can also just go and start multiplying. Like you could take 5 times 180 and then divide by 4 if you're not maybe quite sure how to do some reducing here. I do think, though, 4 goes into 180. Anyone know how many times? 45. So then all you'd have left in your fractions is you have a 5 from the first fraction and a 45 from the second one. So what would that come out to be? Good, 225 degrees. Okay, now before we move on to the next page here, let's talk about how this relates into our circle. So I'm going to draw in 2 lines here to my circle. I'm going to draw 2 different diameters, and I'm going to do my best to make one be horizontal and one be vertical so that they make like 4 quadrants. So almost think about you're cutting that circle perfectly into these 4 quarters here. Now let's think about degrees first. Okay, so on this circle, if I'm at 0 degrees here, so this is where I'm starting, I'm at 0 degrees. how many do you think this would be here?
90.
90. If I keep going, how many would it be?
180.
180. If I keep going, 180, I go another set. This would be 270. What are they all increasing by? 90 degrees. And then if you go back around to the beginning and you're back at that 0, that is the same as 360 degrees as well. So all 4 of these quadrants are 90 degrees. So you can kind of think about that in terms of degrees, but let's talk about what that means in radians. Okay, if a full all the way around, we talked about that earlier, all the way around 360 we said was equal to 2 pi radians. What would 180 be? Just pi. What would 90 be?
0.5 pi.
How could we write that as a fraction?
1/2.
1/2 pi?
Yeah.
Maybe pi over 2?
Mhm.
What about 270? If you don't remember, didn't we do 270 up here somewhere? Our very first example, I gave
2
you
pi, or 3 pi over 2.
3 pi over 2. Those are probably the most common radians when you think about a circle. But again, there are others. Like if I started to cut this in increments of 45 degrees, or if I even did like 30 degrees or 60 degrees, there's ways that you could also think about those as radians as well. Okay, but for right now, we're just kind of touching the surface of this stuff. Okay, and like I said, eventually you'll go a little bit deeper as you get into your future math classes. Now, what I would like you guys to do is turn your page over. There are some examples here that go between both ways. So the first 3 are doing what we just ended with, going from radians to degrees, and then the last 3 are going back from degrees to radians. I'm going to give you guys a couple of minutes here to go ahead and do all 6 of those on your own, and then we'll come together and see what you guys got for answers. right, I'm going to start going through these up here. Now, for the first three, you're going 2 degrees. So from radians to degrees. So for all of these, you should have been taking the radians that you had times 180 over pi. Okay, you should have done that for all of them here. So hopefully you guys had that set up this way. So I'll just write that out for all three. Now again, on all three of these, then the pi's should cancel. So I'll just cross all these pi's off. And then you're just working with the numbers. Now, as far as working with the numbers goes, if you're reducing before you kind of multiply together, that's fine. If you're just taking, like on this first one, 5 times 180 and then dividing by 6, that's okay too. It doesn't really matter how you go about it. You should still get the same answer, okay? Anyone have an answer for letter A here?
150.
150. Everyone agree? Okay, how about for B?
135.
135. Everyone agree with that? And for C? 252. Everyone good there? Okay, now on the next three, you should have been taking them, like think about as a fraction, and then take it times pi over 180 instead. And again, you're going to do that for all of these. I would have written them all as a fraction, just so you can kind of remind yourself when you're multiplying with fractions, you multiply across the top, across the bottom. You're not getting your numbers mixed up as far as like what you're putting with what. This time, though, the pi's should not cancel. You should have had a pi in your answer. So it's more so just working with the numbers, reducing, or again, dividing on your calculator and then seeing what your reduced fraction looks like. What'd you guys get for an answer on the first one?
1 pi over 12.
Can I just write pi over 12?
Yeah.
Yeah. You don't have to have the 1 in front of it if you don't want to. How about letter B?
5 pi over 3.
Good. 5 pi over 3. And letter C?
5 pi over 9.
Good. Everyone agree with all three of those? Anyone majorly confused right now? Okay. I'm going to get you guys your homework.